the group 3. Today we want to present amplitude shift keying. My name is Najwa Shazwani. Metric number B0821110079. Firstly, about introduction. Amplitude shift keying is a modulation technique widely used in digital communication system to transmit binary data over a carrier signal. It is a simple and cost-effective modulation scheme that represents digital information by varying the amplitude of the carrier signal. Amplitude shift keying modulation is straightforward to implement, making it suitable for applications where simplicity is desired. By directly encoding binary data into the amplitude of the carrier signal, amplitude shift keying provides an efficient means of transmitting digital information.
My name is Nurul Naziha. My metric number is B08211036. So I proceed with ASK modulation. So ASK modulation is a digital modulation technique used in communication system to transmit binary data by varying the amplitude of a carrier signal. In ASK, a high amplitude carrier signal represents one binary number, example 1, while a low amplitude carrier signal represents the other binary state, which is 0. The binary data to be transmitted is directly encoded onto the amplitude of the carrier signal, resulting in a modulated waveform that reflects the input binary sequence. ASK modulation is a relatively simple to implement and can be achieved using basic analog circuits, making it cost-effective in practical applications. The modulation process in ASK involves extracting the binary information from the received signal by detecting the amplitude variation and decoding them back into the original binary sequence. Next is ASK demodulation. We have two. So one is, the first is coherent demodulation. Coherent ASK demodulation requires the receiver to synchronize its carrier signal with the incoming modulated signal. The demodulation process involves multiplying the received signal with a synchronous carrier signal and then passing it through a low pass filter to extract the baseband signal. By comparing the filter signal with a threshold, the binary data can be recovered based on the amplitude variation. So the second one is non-coherent demodulation. So no coherent ASK demodulation does not require carrier signal synchronization at the receiver. The received signal is squared to remove the carrier frequency and then pass through a low pass filter to extract the baseband signal. By comparing the filter signal with a threshold, the binary data can be recovered based on the amplitude variations.
Hi, good evening. I'm Yilu Huan, so I'll be taking part for Ask Advantages. My matrix number is B0818105777. So ASK modulation is straightforward to implement and demodulated simple analog circuits and encoding and decoding technique. It will make it easy to comprehend and use. ASK modulation is cost effective. It uses simple hardware components, lowering communication system implementation costs. ASK modulation is efficient for low data rates. ASK can be maximized frequency bandwidth by encoding information in the carrier signal's amplitude. ASK's analog waveform transmission make it compatible with analog system. It works with various analog modulation methods to support legacy systems. So for the ASK disadvantages, it will be more ASK modulation is particularly vulnerable to noise and interference. The variation in the received signal's amplitude can cause demodulated signal fog, reducing signal quality and perhaps data transmission problems. The next is ASK modulation relies on amplitude variation, which may limit noise immunity. Its noise-induced fog make it unsuitable for noise-critical applications. And the third is it requires a broader bandwidth with FSK or PSK to handle fluctuating amplitude level. This affects spectrum utilization efficiency by limiting the number of channels sent simultaneously in a frequency band. ASK modulation also is sensitive to attenuation and distortion, it making it become unsuitable for long-distance transmission. Long-distance signal degrade, reducing signal quality and communication range. That's it for my part. Thank you.
Hello, my name is Sharvin. My matrix number is B0821100310, and I'll be explaining the MATLAB coding. Okay, as we can see here, on line 4 and 5, we have set the amplitude with the value of 5 and the frequency of value of 8. And on line 8, you will be detecting the binary sequence from the user. In this case, we have used 10110011 for the modulating signal. And on line 11, the sequence will be saved to the variable B. On line 14, the time vector from 0.01 initial until the value of B, the maximum number of the sequence with the increment of 0.01 will be produced. From line 17 to line 19, it will produce the modulating signal based on the sequence that we have typed in. On line 22, it will generate the carrier signal. On line 25, we will perform the ASK modulation from the carrier signal based on the modulating signal. And from line 28 to 30, it will perform the demodulation. From line 33 and 34, it will act as a low-pass filter, as we label it as thresholding. And from line 37 to 49, it will produce a graph for the modulating signal and carrier signal. And from line 52 to 64, it will produce a graph for the ASK modulating signal and ASK demodulating signal. For our output, this is the first output. As we can see, the amplitude on the modulating signal, will show high when the bit is 1 and show 0 when the bit is 0. And the carrier signal with a frequency of 8 Hz with amplitude of 5 volts. And this is the output for the modulated and demodulated signal. The modulated signal will go high when the bit is 1 and will go 0 or not signal will be transmitted when the bit is 0. Then from the demodulated signal, we can receive back the initial binary bits. As we can see, it shows clearly that 10110011 was used initially. So that will be my part. Thank you.
Hello, my name is Nur Aisha Sophia and my matrix number is B0821100479. So ASK modulation is simple and efficient. Simple hardware implementation meets its suit for budget constraint application. ASK modulation directly encodes binary data into the carrier signal amplitude, simplifying encoding and decoding. And disadvantage of ASK modulation, noise and interface can cause demodulation mistake. For reliability, error detection and correction codes are needed. ASK modulation has lower bandwidth efficiency than other modulation technique, limiting the number of channels that can be sent simultaneously within a frequency band. Attenuation and distortion can make long-distance transmission difficult, and system design communication system requirements must be considered while adopting a modulation scheme. ASK modulation is simple and cost-effective. FSK or PSK may be better for noise immunity, bandwidth efficiency, or long-distance transmissions.
Hi, my name is Siti Fatima binti Ahmaduddin and my metric number is B0821100573. I will continue with this conclusion. ASK modulation simplifies and reduce communication system costs. Budget constrained application benefit from its simple implementation and bandwidth efficiency. ASK modulation has restriction, noise and interference require additional error identification and correction. ASK has lower bandwidth efficiency than other modulation techniques, limiting the number of channels in a frequency band. Attenuation and distortion complicate long-distance transmission. Consider the communication system need while choosing a modulation strategy in noise immune, bandwidth, efficient or long distance transmission situation, frequency shift keying, FSK or phase shift keying may be preferred. So we can conclude that even though there are other types of modulation such as uh, um, amplitude modulation, frequency modulation, phase modulation, we can see that ASK is the easiest to understand after we have understand the basic concept. Although it has several disadvantages, the advantages will provide balance it out. So that's all from us. Thank you.